All right, guys, sorry about that. My projector turned off, so let's keep going. We now are going to talk about angular speed and translational speed. So we last said that period is just going to be equal to 2 pi r over v, over that velocity. So we can think of another thing. Maybe we don't have to think of period. We could also think of something called rotation rate. And rotation rate is just the inverse of period. And rotation rate would be measured in revolutions per second. So inverse of period would just be rotation rate. Well, I know that if this is traveling in one full revolution, so I have a particle that's traveling in uniform circular motion and it makes a complete full revolution, that would correspond to an angle of 2 pi radians. So if I wanted to calculate angular speed, I could do so by taking the product of this 2 pi radians, this one full revolution, and my rotation rate, which is just the inverse of period. So that gives me my formula. We're going to symbolize angular speed with this italicized W. So I have this W equals 2 pi over T. T just standing for period. Well, I can relate this angular speed also with period to find the translational speed. So let's do that. Okay, so our angular speed was 2 pi over T. And I want to try to relate this to translational speed. So I want to try to find what V would be equal to. I know that T is the same thing as 2 pi r over V. So if I rearrange this, then I would end up getting that angular speed would be equal to V over R. And I want to rearrange this so I can solve for translational speed, because that's going to be V, and that's going to equal my angular speed times the radius. So angular speed is dependent on rotation rate and period. So I see that I have 2 pi radians over my period. Translational speed is going to be dependent on my angular speed, also times the radius. So this is my formula for translational speed, and this would be the one for angular speed. Okay, so let's just do a quick little check here. We have a particle moves in a circular path of radius r with speed v. It then increases its speed to 2v while traveling along the same path. The centripetal acceleration of the particle will have changed by what factor? So we have 0.25 for A, 0.5 for B, 2 for C, or D would be 4. So if I have 2v for the speed, what would happen to what factor would that change the centripetal acceleration? That would be 4. So if I had 2v, I'm squaring that 2v, so then the 2 would become squared as well. I would get 4, so it would change by a factor of 4. If I could ask this exact same question, but I would want to know, instead of what would happen to the centripetal acceleration, by what factor could the period have changed? So in that case, I know that period is equal to 2 pi r over v. So T equals 2 pi r over v. If I double that velocity, what would happen to the period? The period would, of course, become half. 0.5 would be my answer there. Okay, so let's do an example utilizing some of these formulas. So I have, what is the centripetal acceleration of the Earth as it moves in its orbit around the sun? Now, Daniel, this is for you. Daniel, please let's approximate the Earth's orbit as circular, even though we know that it's slightly elliptical. So we're going to just assume right now that the Earth is going to move in a circular motion, even though it is slightly elliptical. So I do know that the radius from Earth's orbit around the sun is equal to 1.496 times 10 to the 11th meters. I also know that it's going to take, for the period, 1 year. It's going to take 1 year to orbit completely. My goal is to find the centripetal acceleration. So I want to find AC. And I know that centripetal acceleration is equal to v squared over r. So my speed over the radius. Well, I know the radius, but I don't know my speed here. I could use my formula that I have for period, though, because I know that the formula for period is equal to 2 pi r over v. So if I rearranged that, that would be v equals 2 pi r over t. And I know r, and I know t, so I could just plug this in for my speed here, and I could find the centripetal acceleration. So let's do that. So if I do that, I would get my centripetal acceleration is equal to 2 pi r, 2 pi r over t. I would get 2 pi r over t, and that whole entity is squared, and then that's going to be divided by r. So again, I knew that period was equal to 2 pi r over v, over speed. So I just rearranged it, so I would get v is equal to 2 pi r over the period, and I plugged that in for v. That whole entity is squared, and then I still have divided by r for centripetal acceleration. So if I simplify that, I'm going to end up getting centripetal acceleration is equal to 4 pi squared r over the period squared. So now I can just plug in my numbers. So I have 4 pi squared times my radius here, 1.496, times 10 to the 11th meters. And that's going to be over t squared, which is, we said 1 year squared. But typically, we want our acceleration in meters per second squared, because that would be that standard unit. So we're going to have to convert those years into seconds. And just for time's sake, 1 year would be equivalent to 3.156 times 10 to the 7th seconds. And I'd have to square that, because the year's squared down here. So I'd need to make the year squared up here, so that way they would cancel. So I'd have all this ultimately divided by that many number of seconds. My centripetal acceleration that I calculate should end up coming to 5.93 times 10 to the negative third meters per second squared. Okay, so that was us utilizing quite a bit of our formulas here that we just talked about. So if you have questions on this problem, post on the blog, let me know, and we'll talk through it as well.